Welcome friends, welcome you all in my channel Chemistry and History of Molecule. I am Tanmay. So today we will discuss a practice question for exam like CSIR-NET, GATE, JAM, etc. So the question is reaction of this carboxylic containing this double bond containing carboxylic group in terms of this reagent. What is the major product? They have asked and 4 options are given. So in such case, I used to suggest you first try to understand what reagents are given, because multiple stereo centers when given, it is very difficult to predict which will be the product. So it is better to follow the track. So initially I will explain everything in details, and at the end I will try to find out the answer within 1 minute. But I believe when multiple stereo centers are there, it takes sometimes some more time than one minute. So such type of questions are actually time consuming questions. They are easy but time consuming. So let's start. So first, when you have such type of problem where cyclohexane ring is produced or that type of thing given, then you should always think about the cyclohexane's actual conformation, that is chair conformation. So it will help you to predict what is the geometry. Otherwise, if you construct this planar, maximum chance is that you will end up with mistake. First, let's draw this here the double bond, and here the CH2COOH. And what does this iodine Ki means? Actually, iodine is not soluble in aqueous medium. So what it does, in presence of Ki, it forms Ki3, means iodine forms I2 plus I minus to form this I3 minus. You know polyiodide anion formation. It is that polyiodide anion formation. Now it is soluble, but actually it is an iodine carrier. This reagent is carrier of iodide in aqueous medium. So double bond is there, iodine is there. What will happen? Iodination. And when iodination happens with double bond, what does it produce? Produce a bridge iodinium ion, cation, like this bridge bromonium. So let's first draw this story in chair conformation. So generally such type of big groups are preferred when there is no geometry is mentioned. Then you should consider that this big group should remain in the equatorial position. Okay, because in this way it will be able to avoid the steric repulsion minimum. Okay. So now what is this? Here double bond was there, and right now this iodination will occur. So what will happen? So I plus this. Okay. So at this condition, now what could be the situation? So if we draw this carboxyl group properly, this OH. Okay. So this carboxyl group have resonance like this, and in this way electron density increases here. So this carbon center is also delta positive electrophilic, and this thing can attack here to open up this ring. Okay. So what is expected to produce? This hydrogen so double bond oxygen, and this actually it is an equatorial position. Hydrogen is below. So what will happen here? Iodide. Okay, and here this is equatorial, this is actual hydrogen. Okay, so let's draw the product again. This, and hydrogen is below, hydrogen is above and iodide is also below. So I believe they have made mistake. This hydrogen must be above. I believe maybe I made mistake to draw it properly. So this hydrogen must be above. So what is the product right now? If I draw it in plane, this is cyclohexane ring. This is cyclohexane ring. Iodide is on the down. So iodide down. After that hydrogen. This hydrogen is also down. This hydrogen is up. Okay. Another thing is a 5-member ring. And this carbon is attached to oxygen. This is double bond. So this is the product. Now where the structure is matching, this is. Now one thing you must remember. So in such cases you must remember that this is above. So this nucleophilic attack always prefer to have anti-geometry. Okay, this is the statement. So we got the answer right now. Let's try to discuss how to solve this question in 1 minute. First of all, if you also want to try to solve this question in 1 minute, you must draw this chair conformation. Otherwise, you will end up mistake. Okay, and you need to understand the nature of reagent. This is iodination reagent. Okay, iodination. This is iodination reagent. This sodium carbonate is a base, and another thing. Here bridge iodinium will form, and after that you have to focus where the anti-addition is given. For example, iodine versus carboxyl should be anti. This is the first criteria to find out. Here another, and initially to avoid multiple options, you can see this will not happen because decarboxylation will not happen at this condition. And another thing, iodine attached with a double bond, it is not possible. So this is not. So ultimately these two options remain. So how to select this? You can select this by this of nucleophilic versus iodine should be anti. Here also it is down, it is above. So this is the answer. This is not. So in this way, I believe within 1 minute you can try to solve the answer. So this is the end of the discussion. So if you like my teaching, please give a like and share this video among your friends that more people get benefited from my effort. And finally, subscribe my channel Chemistry the Mystery of Molecules, and please press the bell icon to get the notification of every single video I upload. So see you in my next video.